stand beneath an ancient temple, a towering pyramid, or a cathedral-like stone hall carved thousands of years ago, and one question almost always comes to mind. How did people without cranes, computers, steel, or electricity create structures that still stand today? Some blocks weigh more than modern trucks. Some walls align so precisely that even a knife blade struggles to fit between the stones. To many, the answer seems almost impossible. That's why myths about lost civilizations, forgotten technologies, or even extraterrestrials continue to circulate. But the real story is far more remarkable. Ancient architecture wasn't built through magic. It was built through patience, observation, and thousands of years of accumulated knowledge. The earliest human shelters were simple because they only needed to solve one problem: survival. Branches, animal hides, mud, reeds, and stone offered protection from rain, wind, and predators. These temporary homes could be built quickly and abandoned just as easily when food sources disappeared. Everything changed when humans stopped wandering. Around 12,000 years ago, farming encouraged permanent settlements. Once people stayed in one place, temporary shelters were no longer enough. Houses became larger, stronger, and more durable. Villages slowly transformed into towns, and towns eventually became cities. With permanence came a new challenge. Buildings now had to survive not just one season, but generations. The first great architects weren't trained professionals. They were farmers, builders, and craftsmen who learned by watching nature. Trees revealed how weight could spread through branching supports. Mountains demonstrated that wide bases remained stable under enormous pressure. Riverbanks showed how flowing water gradually weakened poorly supported ground. Nature became humanity's first engineering textbook. One lesson appeared again and again. Heavy structures needed strong foundations. Ancient builders quickly discovered that the most beautiful wall meant nothing if the ground beneath it shifted. Many civilizations spent as much effort preparing foundations as constructing the buildings above them. They compacted soil, leveled bedrock, and carefully distributed weight long before the first visible stones were placed. That invisible work often determined whether a structure survived for centuries or collapsed within years. Materials also shaped architectural progress. In regions rich with forests, wood became the primary building material. Along major rivers, mud bricks dried beneath the sun. Mountain civilizations relied on stone. Coastal communities combined shells, sand, and lime to produce early forms of mortar. Architecture evolved differently because landscapes offered different resources. No single invention transformed construction everywhere. Instead, each civilization mastered the materials surrounding it. Perhaps the greatest breakthrough came from simple observation. Builders noticed that stacking stones directly upward eventually caused walls to crack under their own weight. But gradually sloping the sides outward, as seen in pyramids, distributed pressure far more effectively. Likewise, placing long beams across wide openings often caused them to snap. Problems created innovation. The arch was one of those innovations. By arranging wedge-shaped stones so each pressed against the next, ancient builders redirected weight sideways rather than straight downward. Suddenly, larger doorways, bridges, and halls became possible without collapsing under their own mass. The Romans later perfected this principle, using arches to create aqueducts, amphitheaters, and monumental public buildings that transformed the ancient world. But arches weren't the only solution. Across South America, the Inca developed an entirely different approach. Rather than relying heavily on mortar, they carved enormous stones into irregular shapes that locked together like puzzle pieces. The precision was astonishing. During earthquakes, these stones could shift slightly before settling back into place, making many Inca walls remarkably resistant to seismic activity. It was engineering shaped by the landscape itself. Egypt followed another path. The builders of the pyramids mastered large-scale organization more than any secret technology. Quarries supplied millions of limestone blocks. Teams transported stone using sledges across carefully prepared surfaces, while surveyors aligned structures with astonishing accuracy using stars, shadows, and simple measuring tools. Every achievement rested on planning, not miracles, Mathematics quietly became architecture's greatest ally. Ancient surveyors measured distances using ropes marked at regular intervals. Right angles could be created with surprisingly simple geometric methods. Repeating proportions ensured buildings remained balanced and symmetrical. Long before calculators existed, builders understood patterns. Those patterns produced stability. Astronomy also influenced construction. Many temples, pyramids, and ceremonial sites align with the rising sun during solstices or equinoxes. Others point toward important stars or constellations. These alignments weren't decorative. They connected architecture with calendars, agriculture, and religious ceremonies. Stone became a way of measuring time. Construction itself required extraordinary teamwork. A single monumental project involved quarry workers, transport crews, stonecutters, carpenters, rope makers, tool makers, surveyors, cooks, water carriers, and administrators, keeping everything organized. Ancient architecture wasn't the achievement of isolated geniuses. It was the product of entire societies working together. Mistakes also played an important role. Collapsed walls taught builders how much weight certain materials could bear. Cracked foundations revealed weaknesses beneath the soil. Every failure became another lesson passed to future generations. Knowledge accumulated slowly. Each generation inherited solutions discovered by the one before it. This process explains why architecture advanced steadily rather than appearing suddenly. One civilization improved quarrying. Another refined brickmaking. Someone invented stronger mortars. Someone else discovered better lifting techniques using ramps, levers, rollers, and carefully coordinated labor. Progress rarely came through dramatic breakthroughs. It emerged through countless small improvements. Decoration eventually became as important as structure. Columns evolved from simple supports into works of art. Walls displayed carvings celebrating rulers, victories, or religious beliefs. Bright pigments covered buildings that today appear as bare stone. Ancient cities were often far more colorful than modern ruins suggest. Architecture communicated identity. A visitor could understand a civilization's beliefs simply by walking through its streets. Perhaps the greatest misconception about ancient architecture is assuming builders worked without sophisticated planning. In reality, many projects required decades. Some lasted longer than the lifetimes of those who began them. Workers knew they might never see the finished structure. Yet they continued anyway. That willingness to build for future generations reveals something profound about human ambition. The most enduring monuments weren't created for immediate reward. They were investments in memory. Even today, engineers continue studying ancient techniques. Roman concrete has survived marine environments for nearly 2,000 years. Inca masonry still resists earthquakes. Egyptian stonework remains astonishingly precise despite primitive tools by modern standards. Ancient builders still have lessons to teach. Perhaps that's the greatest surprise of all. Their achievements didn't depend on lost technology. They depended on careful observation, relentless experimentation, organized cooperation, and an extraordinary willingness to learn from experience. Every towering temple, palace, pyramid, fortress, and bridge began with someone asking a simple question. Can we build this? Then another. Can we build it better? Those questions echo through every skyline on Earth today. Modern cities may rise with steel cranes and computer models, but they stand on foundations laid thousands of years ago by people who proved that intelligence isn't measured by the tools you possess. It's measured by what you manage to create with them. The world's oldest buildings aren't reminders of impossible mysteries. They're proof of what ordinary human beings can accomplish when knowledge is shared, curiosity never stops, and each generation leaves the next a stronger foundation than the one it inherited. Another overlooked achievement was maintenance. Ancient builders understood that even the strongest structures required constant care. Temples were repaired after earthquakes, damaged stones were replaced, wooden beams were reinforced, and drainage systems were cleared to prevent water from weakening foundations. Architecture wasn't viewed as a finished project, but as something each generation inherited and protected. This long-term mindset explains why many monuments survived for centuries while countless others disappeared through neglect rather than poor design. The true genius of ancient architecture wasn't simply constructing remarkable buildings. It was creating structures and building traditions resilient enough for future generations to preserve, restore, and continue using long after their original builders were gone.